So this is my take on Apollo 13. It's another short talk. I'm not going to go into all of the details that you would have gleaned by looking in the Apollo archives or by watching the 1995 film with Tom Hanks. So let's just set the scene. The mission started much the same as the previous Apollo missions. Apollo 8, not 9, remember 9 stayed on the Earth, but 8, 10, 11 and 12 launched with the Saturn V taking the astronauts to the moon. And the astronauts were, from left to right, the command module pilot, Ken Mattingly, the commander, Jim Lovell, and the lunar module pilot, Fred Haise. Now, unfortunately, the command module pilot was, well, all of them were exposed to German measles, but the command module pilot hadn't had German measles before, and so he had to step down. So Ken Mattingly, at almost the last minute, was replaced with Jack Swigert. So that was the final team, as it were, the team that went on Apollo 13. And of course, the story of the Apollo 13 accident, and more importantly, perhaps, the heroic efforts of those in mission control to get the 3 astronauts safely back to Earth, that was told, excuse me, or you could argue immortalised by Hollywood in the 1995 film, some 25 years after the accident, which of course is now 25 and a little bit more than 25 years old, and that's a rather sobering thought in its own right. So if you're going to have a Hollywood film, who do you get to portray the 3 astronauts? Well, Hollywood has its own idea of what a heroic astronaut looks like. So that's one way of portraying the crew, but that doesn't work too well. So they had to come up with the relevant actors. And the actor playing Jack Swigert was Kevin Bacon. The actor playing Jim Lovell was, of course, Tom Hanks. And the actor playing Fred Haise was Bill Paxton. So those are the individuals. It's almost got to the point where if you've seen that film a lot of times, you tend to think that's what the astronauts actually looked like. You forget what the real people look. You tend to associate these names with the faces of the actors. Excuse me a second. So we're back to the idea of reality and Hollywood. So yes, it was immortalised by Hollywood in the 1995 film, but it's perhaps appreciated a little less that Apollo 13 was actually immortalised in a different way. And that was, it was immortalised in Lego. Yeah, fantastic. So a Lego Apollo 13 kit. You can see here the command and service module and the lunar module, the astronauts, but key to the whole Apollo 13 story is the mission controllers, the flight director, the engineers, and everything that's going on in mission control. Apparently 492 pieces, it says, for this particular project of Apollo 13. If we have a look at the mission control, I think this is rather wonderful, as well as the display of where the astronauts are on their way to the moon, etc., and the patch of the mission. We see the mission controller's desk, the big red phone, we have the flight manuals, and most importantly, we have a cup of coffee to make sure that the mission controllers can do their jobs. The mission controllers themselves, we have a flight dynamics officer on the left. We have a rather stern-looking flight director with a buzz cut in the middle there, and we have an aeronautical engineer on the right who appears to be doing an awful lot of sweating with a bit of a grimace, presumably because it fell to the engineers to try and figure out what they were going to do to get these 3 astronauts back once they had the problems on their way to the moon. And although it doesn't actually say so, it says flight director, but it looks like this individual is probably modelled on Gene Kranz, though other flight directors are available for those in the know. If we have a look at the Lego astronauts, we see in the middle there, we've got Lovell, the commander. On the right, looking almost as cheerful, we have Haise, the lunar module pilot. But notice that Swigert on the left has again somewhat of a grimace, presumably because it was Swigert that flicked the switch that caused the spark, that caused the explosion, that caused the problem. So nobody blames Swigert for the problem, but perhaps that's why LEGO decided to give each of the astronauts a slightly different face, and they gave Swigert the slightly grimacy face there on the left-hand side. The actual LEGO of the command and service module and the lunar module, of course they're rather crude because it's only a small size kit, this particular one. And so we have a limit to how many pieces we can use to make the command and service module and the lunar module. And the explosion which occurred in the service module here, it looks like the LEGO kit comes in two versions. The version pre-explosion and the version post-explosion, where you actually see the guts of the service module exposed by the fact that one of the panels has blown out after the oxygen tank exploded. So I thought it was quite a nice touch that you have the option of building it one way or the other way. Not as detailed as, for instance, the lunar module, which some of you might have seen. This is the lunar module that was brought out for the 50th anniversary of Apollo 11, so more pieces, larger scale, and hence more structure that you can see within the lunar lander compared to what we were looking at in the Apollo 13 kit there. Let's remind ourselves of some of the abbreviations that are used when we're talking about the various parts of the Apollo spacecraft. We have the service module, the essentially cylindrical part that provides all of the power and water and oxygen for the astronauts. The astronauts live in the conical section in the middle there, the command module, and on the right we have the lunar module, which is, as we'll see, the part that takes the astronauts down to the lunar surface. The service module is usually abbreviated simply SM, the command module CM, and the lunar module LM. In its older days it used to be abbreviated to LEM, the lunar excursion module, and hence a lot of people still call it the LEM. The command and service modules spend most of their time together. Most of the mission is spent with the service module coupled up to the command module, and so they're treated as a pair and often referred to as the CSM, the command and service modules. So let's have a quick look at what was supposed to happen. What was the mission profile for getting men on the moon for Apollo 13? It was a similar profile to 12 and 11. Let's just remind ourselves how it was supposed to work. After the Saturn V got them in orbit and the final stage booster rocket sent them on the way to the moon, then the command and service module and lunar module would effectively coast for 3 days on the way to the moon. The 3 astronauts would spend most of their time in the command module, but of course the lunar module is available to them and is powered up, and once they reach the moon, 1 astronaut would stay in the command module and 2 astronauts would then transfer into the lunar module in preparation for the lunar mission itself. Once everything was tied down and everything was ready, they would close the docking hatch between the 2 command module and the lunar module, and then the 2 astronauts would then descend to the moon. The commander and the lunar module pilot would descend to the moon. Not hanging onto the leg, as I've indicated here, but of course inside. They would then do their excursion for hours or days, depending on how long the mission was designed to last, and when they were ready they would climb back into the ascent module, which would then use the descent stage as a sort of a takeoff platform, and the ascent module would eventually return back to lunar orbit, where it would rendezvous with the command module and the astronauts would be reunited. The 2 astronauts in the ascent module of the lunar module would then reunite with their comrade back in the command module, and at that point the ascent module of the lunar module no longer has any job to do. It's only designed to keep 2 astronauts alive for a couple of days or so, and once it has done its job of returning the astronauts back to the command module, it would then be jettisoned. And depending on which mission, it would either then go into solar orbit or it would end up crashing back into the moon. Once we have our 3 astronauts back in the command module, they would then start their journey back to the Earth. And again, that would take about 3 days. Once they arrive back at Earth, shortly before actually splashing down in the ocean, they no longer have any any need for the service module. That's been providing them with power and oxygen and water for the past week or so. Now that they're back close to Earth, they no longer have any need for the service module, so that would be jettisoned and that would burn up in the Earth's atmosphere. And then finally, the 3 astronauts in the command module. The only part to return, of course, is the command module itself, the small conical command module. That would then splash down into the Pacific Ocean. This particular graphic, kaploosh, there it is. This particular graphic appears to show the Earth, and it looks like the Indian Ocean there, simply because I didn't find a picture of the Earth with the right rotation. But of course they splashed down in the Pacific, a larger target to hit, rather than the Indian Ocean. So that was how the mission was supposed to go. So what actually happened that was different? Well, pretty much everything. Not for the first day or so, but from there onwards things were very different. 2 days into the flight, up to that point everything was pretty much textbook, but about 2 days into the flight there was a large bang. Houston, we've had a problem. Not quite said that way in the Hollywood film, but almost word for what was actually said at the time. There was a problem. There was an explosion in the service module. At the time, they couldn't see what the problem was. This photograph is from much later in the mission. I've shown it out of time order just to show you what had actually happened. The side of the service module, one of the panels had blown away because of an oxygen tank that had ignited inside. The fuel, the oxygen, and the hydrogen inside the service module, the cryo tanks, which keeping all the fuel nice and cold, they're stirred every once in a while to make sure that the fuel doesn't end up layering out. So a fan inside one of the oxygen tanks was designed to be switched on to stir the oxygen, to homogenize, if you like, the fuel inside the tank. Well, it wasn't known at the time that one of these fans had faulty wiring because of a test that was done some months earlier. A test had overheated the wiring without them realizing it, and the wiring insulation had basically melted, and they didn't realize that because it was all inside the tank. So when the cryo tank was stirred on this fateful hour by Schweigert flicking the switch, well, there was a spark and the oxygen tank exploded and took out not only itself, it took out the neighbouring oxygen tank and the fuel cells as well. And the overpressure of oxygen blew off the panel. So they had a loud bang and they saw oxygen venting. They knew they were in trouble. And it didn't take them long to figure out, if we're losing power from the service module keeping the astronauts alive in the command module, we need to use the lunar module as a lifeboat. So very quickly it was decided that all the astronauts would move into the lunar module, and effectively they powered down completely the command and service modules. They basically switched everything off, hung up a sign saying "gone fishing," and abandoned that part of the spacecraft. They couldn't afford the power requirements to keep that ticking over, either in electrical power or in temperature. So they simply let the spacecraft effectively freeze. So what do you do now? There were actually contingency plans for what would we do if the service module was crippled and we need to get back from the moon. In other words, if we're at the moon and it's a 3-day flight home, what's the contingency plan? That had indeed been thought about. It had been worked through. One of the astronauts that was tasked with figure out a contingency plan for getting home from the moon if the command module is compromised, one of those astronauts, it was Schweigert. So in a sense, you had the best man for the job trying to figure out what needs to be done. But they're not 3 days from Earth because they're still on their way out to the moon. It's very difficult to stop, turn around and come back again. That needs a huge amount of fuel, and they're not sure that the main engine on the back end of the service module is working. So they decided to continue to the moon, swing round and come home. So that's 4 days, not 3. So they'd figured out just about how to survive a 3-day return home limping with a crippled command module, but they hadn't figured out how are we going to do it and how are we going to survive 4 days. Do we have enough power? Do we have enough water? Do we have enough heating? Do we have enough oxygen? And can we actually stay warm for that length of time? So they carried on to the moon, and instead of going into lunar orbit, they simply went round the moon, did a figure of 8 effectively, and came straight home again. And of course, it was that long 4-day journey back to Earth that was the problem. They were trying to survive on minimal power. You can't survive on minimal oxygen. You need a certain amount of oxygen, but where possible, you minimize the amount of power you're consuming. And that was the problem, and that's what Mission Control had to figure out. How do we keep them alive? How do we keep the carbon dioxide levels low enough? How do we make sure the power levels give us enough energy in the batteries when we get back to Earth to actually deploy the parachutes, for instance? So I'm not going to go through all those details, because that was A, documented very well by NASA, and B, it's actually an excellent portrayal within the film of everything they had to think about to try and make sure the astronauts survived. So that story, Tom Hanks has told that as well as anybody. So they are a long way from home, but I'm sure they are very grateful and very cold by the time they get to the point where they can see the Earth getting larger and larger out of their windows, and they realise they are almost home. By stretching the power, stretching the water, they have managed to make it back home again. Now that they are within shouting distance of the Earth, they can transfer back into the command module and power it up again. That was no mean feat. Again, the details are covered in the film. They had to worry about the order in which they switched everything back on in order to make sure that they could boot up all the systems they absolutely needed to make sure that they could have a safe re-entry. At this point, they realised that, right, we've got all the power we need. We're still drawing some power from the lunar module. They had a cable running between the two to transfer power from the lunar module to the command module. So they were still sapping some of the power from the lunar module. But at this point they realised, well, we've got a damaged service module. It's not doing us any good. And at this point they said, we may as well let it go. So they jettisoned the service module, which then again burnt up in the Earth's atmosphere. And it was at this point that they actually took the photograph whereby they could actually inspect the damage caused by the explosion. They had pretty much figured out what must have happened from all of the post-mortem of the explosion and the venting gases and the loss of power and the loss of fuel, etc. But now they could confirm just how much damage was done by looking at the outside of the spacecraft. At this point, we're in a configuration that's never been used before. Never in any other Apollo mission, or any Apollo mission first, have they had a command module attached to a lunar module preparing for return to the Earth. So at, I was going to say the last possible minute, it wasn't quite the last possible minute, something like a couple of hours maybe ahead of the splashdown on Earth, they said, we've taken as much power as we can use from the lunar module. We now need to sever the link between the two and prepare for the command module to return back to the Earth. So at this point they said, goodbye Aquarius, we thank you. The lifeboat did its job. And then the three astronauts were on their own, praying that everything else was okay, praying that the explosion in the service module hadn't affected the heat shield, and then they came down to a successful splashdown into the Pacific. What a relief. The famous phrase, failure is not an option, was spoken by Ed Harris, the actor, but not actually by Gene Kranz, the flight director during the critical phases of the Apollo 13 mission. The director of the film, the Apollo 13 film in 1995, Ron Howard, interviewed various people and asked, for instance, mission controllers, when you have a problem, how do you go about fixing it? What's the mindset? And the mission controllers gave them various accounts, including, well, if we have a problem, what we do is methodically look at every possible option for fixing the problem. And we look at all of the options, and failure isn't one of them. And Ron Howard thought, great, that is the catch we need. That's far too long. We need to shorten it. And so he shortened it to failure is not an option. So that's what Ed Harris said, even though Gene Kranz has claimed that he never actually said that during the mission. But Gene Kranz did think that that so succinctly does summarize what you think about mission control and the mindset of the mission controllers. He thought it was so succinct, he thought, yes, I'll use that for my autobiography. Even though he admitted he never actually said that, what a great way of expressing the mindset of, when we have a problem, failure is not an option. So he used that, and if anybody hasn't read that autobiography, well worth a read. What happened to the various bits of hardware in Apollo 13? Well, the command module, Odyssey, as it's known by its call sign, made it back to Earth with its 3 occupants, and it's now in a museum. What about the rest of the Apollo hardware? Well, the 3rd stage of the Saturn V rocket, the S4B, after it had accelerated the command and service module and the lunar module towards the moon, it was given one last task to perform. It was crashed into the moon. In other words, it effectively followed the spacecraft on a slightly different trajectory. While the spacecraft went round the back of the moon, the 3rd stage of the rocket was aimed at a particular point on the moon and crashed into the moon. That was done partly, well mainly I guess, to produce a nice moonquake which the Apollo 12 seismometers could record. The previous mission, the Apollo 12 astronauts had set up seismometers on the moon, and by crashing the 3rd stage rocket into the moon at a known velocity, at a known time, at a known place, relative to Apollo 12 landing site, they effectively calibrated the seismometers because they knew an energy impact of a certain amount produced a trace like that. And that then allowed them to trace other moonquakes and impacts of other bodies on the surface of the moon. What about the lunar module, call sign Aquarius? Yes, it was jettisoned just before the command module re-entered the Earth's atmosphere and splashed down in the Pacific. And yes, the lunar module entered the Earth's atmosphere and presumably disintegrated. However, they had to be very careful, and they had to be very careful in particular with the re-entry of the lunar module. Yes, it's very fragile. Everybody knows the lunar module is not designed to move through an atmosphere. It's only designed to go onto the lunar surface and up again. So it's a very fragile spacecraft. So why would that be a problem when it's entering the Earth's atmosphere? Well, they wanted to be sure that any surviving elements, any surviving components of the lunar module ended up in the deepest Pacific trench that they could reasonably find to dump it in. So that might be perhaps elements of the engine, okay, but there was one component in particular that they were very worried about, and they wanted to make sure it was going to get nowhere close to people. And that particular component was the plutonium fuel cask, which is on board every lunar module. Here you see a picture from Apollo 12, and there's Alan Bean taking the plutonium cask from the lunar module, and he's going to place it in that object close to his feet, which is an RTG, a radioisotope thermoelectric generator. In other words, plutonium decays because it's radioactive, and as it does so, it generates heat, and you can use that heat to power the instruments that you're putting on the surface of the moon. So RTGs are a fairly common way of powering equipment that is supposed to be a long way away from humans. Okay, humans were close for a day or two, but apart from that, the RTGs would spend most of their time on the lunar surface a long way from people. And RTGs are used in space probes into the deepest parts of the solar system, for instance. But of course, it's rather important that if you've got plutonium on board the spacecraft, and remember, the lunar module is never designed to come back to Earth. They never factored in the fact that it could come back to Earth. Only when this accident occurred do they realise that the lunar module was going to be re-entering the Earth's atmosphere. So they tried to make sure that the lunar module entered into the Tonga Trench, which is about as deep as you can get in the South Pacific, such that that fuel cask, which they believe is still there and they believe is still intact, is sitting at the bottom of the trench and will live out its days with its radioactive heat slowly decaying away, a long way from any people. I guess you know, if you've seen the film, that that Jim Lovell has a cameo. There's Tom Hanks on the right playing Jim Lovell, but there's Jim Lovell on the left playing a cameo role as the captain of the USS Iwo Jima, shaking his hand as he congratulates him on his return to Earth. Jim Lovell himself, and I guess the other astronauts, were quite confounded by the fact that there was so much hullabaloo. They didn't realise quite just how much the world was engaged with the whole process of rescuing them. Mission Control simply said, "We will get you home." Mission Control didn't necessarily give them all chapter and verse as to just how much publicity was going around the world and how much everybody was wishing them well for their safe return. I don't know who that is on the left-hand side, but it looks like as soon as they've returned to Earth, they've got them signing publicity photos. Ha! That's the life of an astronaut, isn't it? Before I make my last point, let's just tell you who made what. The spacecraft, like the Saturn V rocket, is not made by one company. It's made by a whole set of companies, all of whom put in the lowest bid for the tender. The Command and Service Module and the Lunar Module were made by two different teams. North American Rockwell built the Command and Service Module, and the Grumman Aerospace Corporation built the Lunar Module. Now, of course, in a standard mission, the Command and Service Module does most of the heavy lifting. That does most of the work. It keeps the astronauts alive. It has the main engine, which does most of the propulsion. And the Lunar Module's job is only to go down to the lunar surface and back up again. I say only. I'm not trying to say that's not a wonderful machine, but its job was limited to taking 2 people to the surface and bring them back again. Most of the rest of the mission was devoted to the operation of the Command and Service Module. But of course, in Apollo 13, the Lunar Module became the lifeboat. The Lunar Module arguably saved the mission. So Grumman Aerospace thought, well, not the heads of Grumman Aerospace, but some of the engineers in Grumman Aerospace thought, well, our spacecraft has saved the mission because our spacecraft was the lifeboat. Our spacecraft towed the North American Rockwell Command and Service Module all the way home. We ought to send them a bill for that. So they came up with an invoice. This is an invoice sent from Grumman to North American, apparently without the knowledge of the heads of either of the corporations. But North American Rockwell was sent this invoice, and it was addressed to Houston via the USS Iwo Jima, and Grumman sent them the bill, and the bill is partly for towing. This is the towing bill to get them back to Earth. How much did they charge them? They charged them $4 for the first mile and $1 for each additional mile. So it was roughly 400,000 miles when you take the distance to the moon and then the 3-day journey back. So they've charged them, you probably can't see the numbers, but they've charged them $404,004. $4 for the first, $1 for each additional mile. They also charged them a few other things, like you've been using the Lunar Module power for most of the mission, which you shouldn't have been doing, so we're going to give you a battery charge. Yes, the customers use their own jump cables, that's fair enough, but you've basically been using the Lunar Module power, so we'll charge you for that as well. That's $4.05. You've used a bit of oxygen, a bit of other things, but what about the accommodation? Now, sleeping accommodation for 2 astronauts, by the way, no TV. Yes, it's an air-conditioned room, there is radio, and there's a fantastic view. How much are we going to charge for that? Well, of course, there's no charge because that's part of the mission in the first place. Part of the mission is 2 astronauts will go into the Lunar Module, the air-conditioned, no TV, with a view, Lunar Module. That's part of the mission, so there's no additional charge in this invoice. But of course, Apollo 13 had 3 people in the Lunar Module. So Grumman charged them an extra additional guest in-room charge, and they charged them an extra $8 per night for 4 nights. So there's an extra $32 that was being charged to North American Rockwell by Grumman. A few other minor things as well, and then at the end, no taxes applicable because it's a government contract. And they gave them a 20% discount and basically charged them $312,421 for the invoice of getting them home. As far as I know, North American did not pay the invoice. I don't think the heads were too keen on the fact that their employees had gone behind their back to set up this invoice, but North American, I think, responded with something like, yeah, but if you actually work out the towing fee for all the times it has worked, then you would end up owing us the same amount of money. So they called it quits. I'll finish with an epilogue. That's Odyssey. That's the command module being hoisted out of the ocean by these Navy soldiers on the USS Iwo Jima. You notice that it's, of course, come through the Earth's atmosphere, so a lot of the thermal insulation has been burnt off. You can see some of the honeycomb aluminium underneath. On the left-hand side, you can see some of the thermal insulation has actually survived. The amount of heating is very variable on different sides of the command module. The heat shield, of course, gets very charred, but some of this thermal insulation actually survives. But before they put these command modules in a museum, maybe you've seen the one in the Apollo 10 command module in the Science Museum in London, but you may notice that none of this thermal shielding material is there. They strip it back to the basic honeycomb of the aluminium. So what they do before this goes into a museum is they strip all of this material off Odyssey. And you can see there's a few square meters of it. What do you do with all of this thermal insulation? Well, one option is you sell it to geeks who are prepared to buy a very, very small amount of those few square meters. In other words, museums around the world have small amounts of that thermal insulation and they will sell it to you for a few tens of dollars. You can own your own small piece of Apollo 13. And I thought that was a few dollars very well invested, simply to have my own piece of Odyssey. Let me finish just with this picture. This was taken, when was this? The 45th anniversary, 5 or so years ago, 2015. An amazing lineup of people who were recounting the Apollo 13 mission. Standing on the left there we have Charlie Duke, and then we have two astronauts, Jim Lovell and Fred Hayes. Unfortunately, Jack Swigert had died in 1982. And then we have three of the flight directors. Who have we got there? Gene Kranz, Glyn Lunny and Jerry Griffin. And then we have three astronauts, Vance Brandt, Jack Loosma and Joe Kerwin, some of whom operated as Capcom at various times. And although you can think of it as a problem, you can think of it as a disaster, as was said at the time and as was said in the film, many people regard rescuing the astronauts from the problem was NASA's finest hour. And I believe, as far as I know, all of the gentlemen there, all of those people are still alive today, but it won't be long before we can no longer have this sort of lineup of astronauts and mission directors that we had at the time. Thank you all for listening.